All right, I'm trying to do more random kind of videos as I'm working my way through projects. So here's one. Um, last weekend at our local surplus store, Martin's, I picked up this kind of cute little tripod, um, which, it's not huge. You can see the base, it's not fully extended, and it can go up about 6 or so more inches. Um, and it was listed as a tripod for a mannequin head, presumably for um, like practicing cutting and styling hair, that sort of thing. Um, and on the top, it had this little unit that I've removed, and there's a 1/4 20 thread there, and that feeds into this, and then this bottom part, I'll take it apart in a minute here, can spin freely, so you can spin this thing around. You can use the larger thumb screw to lock this ball joint in place. Whatever, that's not really important. I got this because it was really cheap. I think it was like $5, and I wanted to use it as a temporary stand for an antenna to be able to like pop something up on top of my car while I'm parked somewhere, just to do whatever. And the antenna that I was thinking about is one that I've had for a number of years and I haven't done very much with, and that's this guy. So this is an antenna specifically for NOAA weather satellites. And you can see they broadcast at 137 megahertz. This is a very nicely assembled unit. I got it off eBay from KM4HLF, and it has two more elements that are about 18 inches long that screw in there, but it's very nicely constructed. It's very rigid, and on the bottom there's a I don't know if that's an inch or 3/4 inch inner diameter. Haven't measured it. It's probably 3/4 inch, where you could put this on top of a mast. And I've never really done that because I haven't found a nice way to do it. But so I've had this around for a while, trying to figure out what to do with it. And then I thought, oh, I could put it on top of that and then set it on top of my car or out in a parking lot or whatever to go do some, weather satellite reception. Wouldn't that be cool? And it's almost the right size. It's just a tiny bit too big. And in fact, if you loosen this set screw a little bit more, this doesn't have an end stop. Let me need this so it's second hand here. You can just, now I say that, and now it doesn't want to come all the way out. What's going on here? There we go. So it's just an end pipe without an end stop. Maybe it's flared a tiny bit. But it doesn't quite fit. And I thought, well, I could, I could remount the inside of this. I could crimp down this end. I don't really want to destroy this thing though, and having a 1/4 20 thread on the top, really is pretty useful. So I got to thinking, well, 1/4 20 is real common. I should be able to adapt it pretty easily. And so I started looking at this thing, thinking, okay, maybe I can disassemble this and I can use this for something. So let's see if I can do this single-handed. So take out the big thumb screw, and then there's this little set screw, which is real loose. There you go. And then you see the housing with the ball joint, and then you see the base itself, right, which has 1/4 20 going all straight through the middle, and then the ball joint coupler, and of course it can be threaded straight onto here. And then I realized, oh, this has this nice big set screw in it, so I can literally set that right in there. Ironically, I should be recording this on a tripod, but what do you do? And crank down this set screw so it goes into that groove. And then boom, just like that, we have this mount in here. It's nice and tight. And then I'm gonna set my phone down so I can thread this on proper. I'll move this to the floor. And then boom, just like that, we have our little antenna on a stand that's ripe to be, you know, popped up on the roof of a car, and then that signal gets fed through some coax into an RTL SDR like this, and then we can record it, or we can pass it directly into, I think the software is called WX2IMG, to decode it. But yeah, so quick little project, success, ta-da! Pretty happy with how that panned out. All right, and here is what such a field configuration, as it were, might look like, right? So we've just got both the antenna elements attached, and then it's not threaded all the way in, but I have a you know, a VHF type, you know, PL259 or whatever adapter to SMA, and then here I have an FM broadcast band stop filter. That may not actually be needed once we do some testing, but it's a nice thing to have. Curiously, it's got female threading on both sides, so we have to use a male-to-male coupler to attach it to the SDR. And what I've found is that basically the closer you can get the receiver to the antenna, you know, the better, obviously, right? And that using a long USB cable, you know, like, so this is an example, right? This is actually a USB serial adapter, but I have a couple of USB extension cables that look just like this and are this long. This is about 6 feet long. You know, once the signal is made digital by the SDR, it doesn't really matter. Losses, USB losses don't matter. You want to capture as much of the signal as possible, especially when we're talking about, you know, a satellite signal. And if it's a satellite that's relatively low on the horizon, you don't have a very good lock on it. You know, you don't have, you know, the greatest orientation, so on and so forth, blah, blah, blah. Getting the receiver right on there really makes a big difference. And, you know, to that end, I'll probably test without the band reject filter here first, because, you know, it's, especially since these satellites broadcast at 137 megahertz, they're really very close to FM broadcast bands. There's definitely a lot of room, you know, for potential for that, you know, to overload the front end, and to just use one of these filters and completely knock it out. Plus the losses on these should be pretty minimal. I have another one that I usually use, whoops, wrong box, that I usually use with ADS-B. So here's my ADS-B hookup. And this, it filters out pretty much everything aside from, you know, 1090 megahertz, right? So this wouldn't be useful in this case, but my point is they make these filters specifically for this, you know, 137 megahertz. They just block out everything but that. So that's something that I could use as well. But I think for these purposes, I think this will be perfectly fine. This is a very good antenna. It's very well tuned. In fact, I could show that because I have a VNA. You got one of my absolute favorite tools here, the Nano VNA. And I've got it, I've just got a 50 ohm dummy load on it right now. So we can see we have an SWR pretty much 1-to-1 all across. So let me take that off. I'll put the camera over here. And I know this is not optimal testing environment. This is a very RF noisy room. You know, there's just a lot going on. It's kind of icky, but you can see that, you know, there's the marker and a nice low SWR, and it's right at, you know, 138 megahertz. I could tighten this up a little bit. But given the circumstances, and of course, you know, this is connected directly to the antenna, so it's no cable losses or anything, which is very good. Yeah, but this antenna would perform very well. And I could take the Nano VNA out again when I actually go out in the field and I'm in a much less noisy environment, and we could take a look at how it performs. because it would perform this well, possibly better, likely better. Because I've got monitors, two Bluetooth keyboards, all that stuff, Bluetooth input devices. I got an angry cat, I got a puppy, so